Have you ever seen a crash test like this? Most crash tests are done at speeds between 50 and 60 km per hour, simulating everyday city driving speed. For example, ENCAP's frontal crash test is conducted at 50 km per hour. But research shows that even a small increase in speed significantly raises the risk of injury. For every 1 km per hour increase, the risk goes up by 3%. For every 5 km per hour increase, the danger of a crash nearly doubles. At CATL, we focus on more extreme speed scenarios. We made a bold test. Let's take a look. Yes, we pushed the limits by testing at 120 km per hour. It is a speed carrying 5.76 times the energy of standard ENCAP test. What were the results? We'll get data soon. The results are in, and they are clear. Our extreme test was a resounding success. The crash test just now proved what happens when a vehicle hits an obstacle head-on. Isn't that shocking? There's a far more dangerous situation: accidentally hitting a utility pole, or a big tree, or a gantry on a highway. The area of the center pole crash is only 1/6 of the area of a frontal crash. This can cause huge pressure. We did a test of this situation, and it was successful again. Now, the test subject has been moved to a safe area. Let's take a closer look of today's star, the CATL Bedrock chassis. This is not just any chassis. It's a super safe skateboard-type chassis designed with the philosophy of build around battery. In the crash, the CATL Bedrock chassis absorbed 85% of the impact energy compared to the 60% absorption rate of traditional chassis. If this has been a traditional chassis, it might have caught fire by now. The CATL Bedrock chassis demonstrated remarkable toughness. Apart from the front end, the rest of the chassis sustained minimal damage. Most importantly, the energy unit was almost completely intact. Let's start with the front of the chassis, the first line of defense in any crash. When a crash occurs, the aircraft carrier-grade blocking structure positioned in the front cabin disperses the centrally concentrated force to the side members on both sides, engaging more components in energy absorption. This leads to a gradual deceleration of the chassis, effectively mitigating the intrusion speed when the barrier reaches the battery cells. Now, let's examine the energy unit. It's virtually undamaged, thanks to the innovative 3D bionic tortoise-shell structure. This unique design, formed by the body structure and the battery's framework structure, is fully integrated and deeply coupled. It disperses the impact force evenly and protects the battery cells. And by efficient combination of aerospace-grade aluminum and submarine-grade hot-forming steel, the structure achieves a perfect balance between lightweight and high strength. It's just like a turtle shell protecting its body. Inside, we've incorporated a high ductility, energy-absorbing insulation film. This film not only insulates the battery cells, but also absorbs crash energy to minimize deformation. Worry about the fires you've been hearing about in the news? Don't be. The CATL Bedrock chassis integrates our MP 2.0 technology. It makes sure that even if thermal runaway happens, the heat from one cell won't spread to others, thus preventing a fire. Even under extreme testing, high-speed sled impact at 60 km per hour test, 90-degree bending test, breakthrough sawing test, the CATL Bedrock chassis didn't catch fire or explode. And there's more. We've also made a lot of improvements in areas you can't see. During a crash, the CATL Bedrock chassis automatically disconnects the high-voltage circuit in 1 centisecond, safely discharging any residual electricity energy to prevent short circuit and fire. This extreme test proved the CATL's Bedrock chassis' unparalleled safety and demonstrates CATL's commitment to setting the highest standards for electric vehicle safety. That's all for today's video. Thank you for watching.